properties of matter. So remember that matter is anything that takes up space and has mass. And this is, matter can be anything that you can see, or it can be invisible, such as gases as well. And so matter tends to have physical properties, and these are characteristics of a substance that can be observed or measured without changing the identity of that substance. So examples of physical properties include the ability to conduct electricity, if something is malleable, and malleable means being able to be hammered into thin sheets. Think of like aluminum foil. Let's see. Color is an example of a physical property. Hardness, the ability to dissolve, or solubility, is a physical property. A substance's density, as well as their melting and boiling points. All of these things can be observed without changing the identity of that substance. So a pure substance is matter that has a uniform and definite composition. So an example would be silver, table salt, or NaCl. All samples will have identical properties regardless of quantity. So it doesn't matter how much table salt you have, it will always have a 1-to-1 ratio of Na to Cl, and all of its other characteristics, its solubility, as well as melting point, will all be the same regardless of if you have a teaspoon of salt or a tablespoon of salt. So physical properties can be further divided into extensive and intensive. Extensive properties are properties that depend on the amount of matter in the sample. So for example, mass and volume are both extensive properties. Mass is the measure of the amount of matter that an object contains, and it does not factor in gravity. So if gravity were to change, the mass would still remain the same. Volume is the measure of space that an object occupies. So then the opposite is true of intensive properties, and this is a property of matter that depends only on the type of matter in the sample and not how much there is. So a piece of copper is going to conduct electricity regardless of how much there is of it, whether it's a 2-foot piece of copper wire or a 17-foot piece of copper wire. Color, temperature, density, and solubility will remain the same for any amount of the same object. So why would the state of matter be considered a physical property? Well, it doesn't matter how much you have. Let's say a cup of water versus 5 gallons of water. The substance still is water, H2O. It doesn't matter how much you have. And so that by definition is a physical property. So when we look at states of matter, we have solids, liquids, and gases. A solid is a form of matter that has a definite shape as well as a definite volume. Solids are incompressible, meaning they cannot be squeezed. They can be squeezed, but they won't break. They won't change shape usually. Solids usually expand slightly when heated. And their particle arrangement is very orderly. So when you look over here on this next slide, these particles are very ordered. They are arranged very neatly. So this is representative of a solid state of matter. Liquid is a form of matter that has a definite volume, but not a definite shape. So we call that an indefinite. And the shape will adjust to the same shape of the container. And so if you think about pouring pop from a 2-liter bottle into a cup, your shape of that liquid will change. This is because liquid particles have the ability to flow, which is referred to as being fluid. The particle arrangement is not rigid, meaning it has that ability to move, and it's not orderly. Again, it's incompressible and will also expand when it gets heated. So looking at the next slide, we have liquid particles being represented here. Notice how they are less ordered or less structured than the solid particles to the right of them. The gas is the third state of matter, and this is a form of matter that has neither a definite shape nor a definite volume. The shape and volume of the gas is determined by the container. So when we say container here, this could mean a room. It could mean the outdoors. It could mean a pop bottle. So the word container has a pretty broad definition in this sense. The gas particles are very far apart, and so they are able to move, and this allows them this distance between particles. So one gas particle and another gas particle. So this distance right here allows these particles to be forced together or compressed. So the extra space between particles allows the gases to be compressed. Sometimes gases are referred to as vapor. And vapor is the gaseous state of a substance that is a liquid or solid at room temperature normally. So in order to get a vapor, you have to heat a liquid or a solid. So then lastly, over here in our diagram, we have gas particles in this image. And again, notice all the space between these particles, which allows them to get squeezed together. So the last thing to talk about is changes in these physical properties, and we call these physical changes. And so a physical change is a change to a sample of matter in which some property of the material changes, but it doesn't change the identity of that matter. So these can be reversible or irreversible, and an easy example here is taking liquid water, freezing it, And then we get solid water or ice. But the point is that regardless, it's still H2O, whether it's a solid or a liquid. Another example would be like tearing paper. We now have two halves of paper. So you have your big piece of paper, then you tear it. Well, both halves are still paper. They're just smaller. So the identity has stayed the same. It just has changed shape.